So in this question, we are asked to find the limit of this function as x approaches 1. So let's just look at the numerical way of doing this, right? So we're gonna iteratively plug in values to this function and see what happens as we get closer and closer to values of x equals 1, right? So we could say here we have x, right? And we have f of x, and we have x again, and we have f of x, right? So the reason we have this repeated is because we want to see how the function behaves as we come towards it from both sides, right? So let's look at that behavior. Okay, so let's say x, let's just say, so we're coming, let's say we're approaching x, x equals 1 from the, let's say from the left hand side, right? So we're getting, so let's say, so we have, just draw this number line. Okay, so we have x equals 1 here, right? And we're gonna approach this number from both sides. We're gonna get closer and closer to this number from both sides and see what happens to the function f of x as we do that. Okay, so numbers to the right of the numbers to the right of 1 are, you know, like 1.001, 1.002, etc. You know, we can get arbitrarily close, right? We can get closer and closer. You know, it can be because these are real numbers, right? And numbers below 1 would be something like, you know, 0.991, right? 0.990. Okay, so we're gonna get closer and closer to 1. I'm just gonna, okay, so let's say we have these values for x: 1.002, 1.001, 1.0001, okay? And then we have other x values: 0.998, 0.999, 0.9995, okay? All right, let's just say 0.9999999, okay? So what is the value of this function f of x as we get closer and closer? So we get values like 1.5072, 1.50075, 1.5001, as you, okay, and then from this side we get 1.4988, 1.49925, and 1.49999. As you can see, from both sides we're getting closer and closer and closer to 1.5, right? So both sides approach 1.5, right? So we say the limit of f of x as x approaches 1 is 1.5. Okay.